Welcome to episode 237 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing fine. Don't really have too much news to go over myself. You got anything to share?
Not at the moment, no.
Okay. We will jump right into this piece of feedback then. We got an email from Nis writing, Dear Rob and Jason, thanks a lot for providing a great podcast and for keeping the high quality. I just stumbled upon this announcement of TC Malik, and this is actually on the Abseil blog, which sounds quite interesting. While reading the article, I learned that TC Malik uses Bazel as the official build system. I wasn't aware of Bazel as an alternative to CMake and can't remember if you've ever mentioned it on your show. Could you reach out to someone who can tell us more about Bazel and TC Malik? I feel like we've probably mentioned Bazel. I'm not really sure how popular it is as a build system.
Yeah, surely
as
a news item, I would have to imagine we've mentioned it at some point.
Yeah, but we've definitely not discussed TC Malik before, which was just announced recently.
I'm very confused by this, actually. TC Malik has been around for a long time. Super long time. I used TC Malik professionally in about 2008. And it had already been around and was stable by then. So I'm so confused.
Maybe it was a different TC Malik?
I think it's the fact that it's being integrated into Abseil.
Well, I think they specifically say that you don't have to use it with Abseil, right?
I have no idea. I'm very confused. I feel like
It says it's a distinct repository allowing Abseil to be used independently of TC Malik.
Oh, they've disclaimer. This is not an officially supported Google product. Okay. It's I'm sorry, but you just broke my brain by putting this on here, Rob.
It's okay.
gperf tools. Original Google performance tools. Yeah, I see something from 2011 easily searching. I have no idea what this is and why it's moved to this new repository and what's up with that.
Okay, so it might not be completely new then. Maybe it's been updated recently. I don't know. I mean, it does say it's got optimizations leveraging modern C++ features, including C++ 14 and 17 features. So, it must have at least been updated since 2011.
Agreed.
Yeah. Okay, well, we definitely have not, talked in too much detail on the show about either of these. We feel like I have a bit of a backlog of projects to look up and try to find guests for.
Agreed, yeah.
Yeah, and if you ever have a suggestion like this, or if you're listening and you know something about TC Malik, or I think the last suggestion we had was Fuchsia OS, if you have a suggestion for someone who you think might be a good guest, please let me know. Sometimes it's a little hard to find guests to talk about these topics because there's not a whole lot of public information about them.
Right.
Yeah. Okay. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, email us at feedback@cppcast.com, and don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Barry Revzin. Barry is a senior C++ developer at Jump Trading in Chicago, a research and technology-driven trading firm. After programming for many years, he got really into the nuances and intricacies of C++ by being unreasonably active on Stack Overflow, where he is the top contributor in C++ 14, 17, and 20. A lot of his C++ knowledge comes from just answering questions that he doesn't know the answer to, especially when he answers them incorrectly at first. His C++ involvement escalated when he started attending standards committee meetings, having written dozens of papers for C++ 20, and already a few hoping for C++ 23. Outside of the C++ world, Barry is an obsessive swimming fan. He writes fun data articles for SwimSwam and also does analytics for the DC Trident, a professional swim team with multiple Olympic gold medalists, including Katie Ledecky. Barry, welcome to the show.
Hey, great to be here.
Wow, I just, that is a wide-ranging things. I'm just, want to ask about the swimming thing. What is SwimSwam?
Yeah, what is SwimSwam?
Yeah, SwimSwam is just a swimming site. It covers all things swimming news related, college, high school, world, Olympics. Um, it's a it's a great source of what you want is swimming news, really.
And I'm guessing you got into this by like being in competitive swimming at one point?
Yeah, so I used to swim competitively, and I still do. I compete in masters.
Okay.
I was never very good on any level, but I like the sport, and I've been like an obsessive fan of it, like on the world level, and I just like somehow got into writing for the magazine, writing for the site. It's been a ton of fun.
That's cool. Okay, well, Barry, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about, other stuff you've been interested in, okay?
This first one's a doozy, just for the record. So,
Yeah, this first one is a blog post from Howard Hinnant, and it's how I declare my class and why. And I guess just to quickly summarize what he's trying to say here is, a lot of people, myself included, will usually put like public API methods at the top of a class definition, and he's saying that's wrong, and you should be putting your private data members on the top. And I'm not sure if I agree with this. What do you think, Jason?
oh, I want to ask Barry what he thinks
Yeah.
of this article first before I go on some rant.
Yeah, so I actually pretty much agree with the article, especially like the gist of it. I find that, the number of data members a class has tends to be pretty small, right? Like most classes, probably 3 or less. Really, most classes like 10 or less. So the amount of space that those data members take up is going to be pretty small. And, I find that when I'm looking at class definitions, it's kind of like either I don't care about the data members, in which case if they're at the top, it doesn't cost me anything to scroll through them. Or I do care about the data members, in which case if we're at the bottom, it's just like an arbitrary amount of stuff that you have to look through to find them. And so that I do find that like putting them at the front makes it a lot easier to really understand what's going on if you care. And if you don't care, then it really doesn't matter where they are anyway.
So the sticking point for me on this is, when do I care about private data members as a user of a class? Like, in what scenarios?
Well, sometimes I want to know like what's actually going on in the class. How's it implemented? What are like the details like that around it?
Okay.
What's the storage look like? What are like the copy semantics, that kind of thing? I mean, if all I'm looking for is what the public API looks like, then yeah, it's totally irrelevant, so you don't care. But then in that case, it doesn't matter where the members are.
And in that case, maybe you're not even looking at the header file. You're looking at the Doxygen output or something,
Sure.
That's true.
perhaps. This is, just for the record, is polarizing on Twitter. If any of you followed that, there's lots of people complaining on both sides of the aisle here, I think.
I don't know. I've never seen a polarizing discussion on Twitter before.
Oh, right. Yeah, sorry, my bad. It must have just been the way I interpreted it. Okay, yeah, all right, I accept that. I don't feel like I have really strong opinion, except for like what I already said. Like, why do I care about the private implementation of it? Although your argument that if you do care, then it's there up front for you to see in one place.
I mean, I can't say for certain what I actually do in my classes. I'm pretty sure I do it semi-randomly.
Right.
But if I were actually having the kind of focus that I wish I had, then I would probably consistently put them first.
That's a good argument right there. Like, just having a plan is probably better than what 95% of us do.
Probably true. Okay. Next thing we have is a new library called Quill, and this is an asynchronous low latency logging library, and it's got some pretty impressive metrics to compare itself against other popular C++ logging libraries. But the thing I like the most about it is it's using the format library for for how to log different strings and output to it.
Format all the things.
Format all things.
Holy cow, it's faster than speed log.
Yeah. It's a lot faster than speedlog.
Yeah, but I think the way that works is that it does its formatting. So speedlog formats up front, right?
Yes.
And then it pushes that formatted thing wherever. Versus, I think in reading this, like Quill stashes all the things it needs to format and does them later.
Yeah, asynchronous. It sounds like it's running in a thread or something. Which then did raise questions for me, which I would love to have both of your opinions on personally. Because whenever I, make some sort of tweet or argument about stop using endline, I get the inevitable backlash from people that say, oh, but I need that flush because if I'm using IO streams, I want that to be written in case my program crashes. Okay, fine. But this being an asynchronous library, asynchronous logging library, what happens if your program crashes? Do you not get that last bit of logging data that might have been critical? Do we care? Does anyone have an opinion?
I mean, I haven't looked into the library to determine if you would, but I would imagine you definitely don't want to lose that logging output when your program crashes because it might tell you why you're crashing.
But if it's asynchronous, there has to be some window that you're going to lose data.
Right.
Yeah, I mean, that's inherent in the problem, right?
Right. So then would you use this logging library?
Yeah,
I mean, is that specific to this one or any other kind of asynchronous logging library?
Well, yeah, just in general, would you use an asynchronous logging library? I have actually written asynchronous logging code before, and for me it worked. So just for the record, I'm not trying to bash on this library. I'm just, just trying to feel out the opinions.
Yeah, I mean, I would say so because, as you can kind of see here, it's a pretty significant cost of doing your formatting in line.
Right.
Yeah.
And if that matters, that's probably not a cost you want to pay.
Right.
Yeah. Yeah, so if it's something that's generating just a ton of data, like, I don't know, a game engine or something, that you want to log all these things. Yeah.
Okay. And then the last thing we have is a post from John Kolb on his website //info, and it's Are You Ready for C++ Now?, which is coming up pretty soon. And in this post, he's basically putting out his opinion that even though some people think this conference is very much aimed at experts, you should not feel intimidated and afraid to attend C++ Now if you are interested in seeing what's happening in C++.
Are you going to be going, Barry?
I've never actually been to C++ Now. I've had a lot of people try to convince me that I should go, and I'm still not going this year. But maybe someday I will actually go.
It is a great conference, and definitely just to agree with John, you shouldn't feel intimidated to go. Everyone's friendly. I feel like I have, no matter how much I've learned, I've always been in the 50% of what's going on I fully understand, and 50% I don't. I don't know how that keeps happening year after year, but
Well, John has a good point in here that if you attend a conference and you're not surprised or blown away by some of the content you see, then what's kind of the point of you even attending?
Right. I will not be making it this year, though. That is official at this point. I have training that will be overlapping with it.
Oh, okay. Okay, so Barry, do you want to tell us a little bit more about the work you're doing at Jump Trading? I mean, is there more you can tell us about it?
I mean, there isn't really too much I can talk about besides just to say, I find the work really interesting. It's a very complex problem space. The problems are really challenging. And so the work's a lot of fun, even if I can't get into too much specifics.
So you have to do lots of really fast things.
Yeah.
Okay.
Okay, that's fair. Do you want to tell us a little bit more then about how you got involved in the C++ committee?
Yeah, I mean, I just kind of fell into it. I just decided to show up to the OLU meeting in 2016. I don't really know anything about it too much. And then, I just kind of started going regularly after that. It's a really kind of interesting and challenging place to be. You kind of learn that once you start going to these things and getting involved in like what the discussions around proposals are like, you kind of find it's fundamentally like a people problem, right? Like any given problem, there isn't necessarily like the one obvious solution, and you have a lot of issues that you have to deal with, right? Like it's an old language. There's a lot of code that exists in it, and you can't just go breaking things for convenience. And so it's a lot of things are just like really hard to try to introduce as a result of that. But it's fun. I mean, I really enjoy it personally. And
So
it's
that
So you
important.
said, yep,
Sorry.
go ahead, Jason.
No, go ahead, Rob.
So you said you first went in the ULU meeting, which I believe was when C++17 was getting finalized.
Yeah.
Did you have any papers that you were able to get accepted during like the C++20 timeframe?
So I don't have anything in 17. I do have a lot of things in 20.
Okay. What were some of the papers you got into 20?
So I guess the ones I'm most associated with lately are all the spaceship related papers. So a lot of changes to the way the spaceship operator works, especially with regards to equality. We kind of split those up after a spaceship first was adopted, and then plumbing it through like the whole library and doing all the work there.
So for our listeners who don't know, could you give them an overview as to what Spaceship is? What is the point?
Yeah. So what the spaceship operator does is it's a three-way comparison. So in C++ historically we've kind of had equality and less than as the two primary operators, and both of them just say true or false, right? You get like that one bit of information. And what the three-way comparison operator does is it basically says it gives you like the full range of the solution, right? Like you compare two things and you get if it's less than, greater than, or equal to as one operation. And it also has a way of expressing a partial ordering. So for a lot of operations, you might not have a trichotomy there. So you can get the result that these two objects are not ordered with respect to each other. And so the other relational operators can be trivially rewritten in terms of a three-way comparison, right? So A is less than B is the same thing as saying that the ordering of A and B is less than, right? And that rewrite isn't always doable in the other direction, right? One of the problems is, it's easy to say that A greater than B is the same as B is less than A, but you have this problem with less than or equal to, in that there are really two ways that you could write less than or equal to. You can say A is less than or equal to B means not B is less than A, which is a valid transformation if you have a total ordering. But if you don't have a total ordering, then that's not a valid transformation, and you might get the wrong answer. So the only way to really get the correct answer is to write it as A is less than B or A equal B, but that's twice as expensive for a lot of types for which you do have a total order, right? So you kind of have to make a choice. And the standard library kind of makes two different choices depending on the types. For most types, it does write less than or equal to in terms of not less than. So like that's how pair works and tuple and vector and all those types. But for optional and variant, we went with the correctness route, and instead less than or equal to just forwards down to the types less than or equal to.
Mm-hmm.
I think this was like Tony Van Eerde's paper where he pointed out that if you compare floats, you get one answer, but if you compare optional floats that contain the same values, you would get a different answer because floats are not totally ordered. And so the goal of Spaceship is to make it so that all the relational operators can be correct, and you only have to write Spaceship to get that to work for you, which is pretty nice. Because Spaceship itself is also much easier to implement than less than, just because you only have to do the one thing and it's easier to reason about.
It's interesting. I feel like most people talk about it in terms of convenience and that it gives us this way of only implementing one thing, and I don't think I've ever heard anyone talk about it in terms of correctness. So I appreciate that.
Yeah, convenience is obviously like a very big thing too, and the fact that you can just default Spaceship and you don't even have to write any code if all you want is just a simple member-wise comparison. That's super nice.
So if we do whatever, what does that look like? That's operator less than, equal, greater than, something equals default?
Yeah, so auto, operator, less than equals greater than, open paren, type, const ref, close paren, const equals default.
Okay. And then
it's
it'll
important to
generate
have
all the...
both consts as well.
So how does that work from like an implementation standpoint? If the underlying types in my struct aren't greater than comparable for whatever reason, then is the explicitly defaulted one take that into account?
Yeah, so what defaulted Spaceship does is it'll effectively, in the same way that a defaulted copy constructor will try to copy construct all of its elements, defaulted Spaceship will use Spaceship on all of its elements.
Okay.
If you use auto as the return type, and so if those types don't have Spaceship, then that operator becomes deleted, defined as deleted.
Okay. So what were some of the changes that had to be made to Spaceship Operator from the kind of initial proposal from Herb?
So the big kind of fundamental problem is that, so Herb's paper was this is like your one-stop shop for all things comparisons. You write one operator and you get everything. So that's obviously like a huge convenience win. And so even like equals, so if I write like A equal B, that will invoke Spaceship and check that the result is equals. But there's a lot of types for which you want to use a different algorithm for equality than for ordering. So if you think about strings, right? Like I know right off the back that two strings of differing size are not equal.
Right.
Mm-hmm. I can easily short circuit on the size there, but I don't know right off the back what the ordering is, right? Because like a shorter string could be greater or less than a longer string. Okay. So if you rely on Spaceship to get your equality, you're severely pessimizing things like string equality, right? Which you might think is fine. You will just write like a custom equals for your string, and not equals, and that works. But this has compounding effects when you start wrapping these types. Because if now I have a struct that has a string member and I just default Spaceship, I just got a slow equals. And so it's basically not really feasible to be able to write like fast code, because like you just have to be constantly aware of any time you write this that like it's not even does my type have to have a fast equals, it's does any type that my type depends on anywhere down in its hierarchy have a different equals. So what we did was we split the two completely. So now all the relational operators are like the secondary operators of Spaceship, and not equals is just a secondary operator of equals, and equal and Spaceship are the two primaries, and otherwise those are just like independent things. And part of the reason we did this is we looked at other languages, and like this is the model that a lot of other languages use as well, is that you have equality and you have ordering, and they're like just separate things.
Okay, that sounds like it makes sense. Yeah. What other languages were you looking at that had similar constructs?
D, Rust, Swift, Kotlin, Haskell, I believe.
Good old Haskell.
Yeah.
So is there anything else then in Spaceship that had to be addressed besides the equality comparison?
Yeah, so one of the problems there is, when I wrote that paper, which is P1185, if anyone's curious, what I did was, Spaceship has this nice feature where it's symmetric and reversible. So, if you have like two different types, T and U, and you write like one Spaceship that can with a T on the left-hand side and the U on the right-hand side, I can write T is less than U, or I can write U is less than T, and all of those work and find your one operator, and you don't have to write like all these permutations of things, which is super nice. So I approached it as, it's really important for if we're going to have these two primary comparison operators that they have the same rules. So we're like, sure, let's just have the same rules for equal, and let's make equal reversible and symmetric, so that if you want to compare a T and a U, you can just write one operator equals that takes a T and a U. You don't have to write that in both directions and then the not equal in both directions as well, right? So you can write one equality instead of four operators.
Okay.
The problem is that ends up actually just breaking a lot of code. And that's actually, unfortunately, that's still kind of the status quo right now. So when I mention that, it's important to write the two consts when you write your comparisons. So there's a lot of code that exists today that has a non-const operator equal that takes a const object as its argument.
You're saying operator equals, just to be clear.
Yeah, operator equal.
All right, just to make sure.
Okay. As a member function that is not const.
Yes, I have recently run into code that was incorrectly written like that.
So in C++17, I mean, you could say that that's like not the correct way to write that, but if all of your objects just happen to be non-const, that's fine. Like that'll compile, it'll work, it'll do the right thing. Yeah, you'll never notice. The problem is with the 20 rules, because we have these like additional reversed candidates, that operator becomes ambiguous with itself. Because we consider the reversed version of that as a candidate, and we have one parameter has a, one of them has a const qualification in one parameter, and the other one has a const qualification on the other parameter, so neither is better than the other, and we're stuck.
Right.
Yeah, so that, sucks. So right now, Clang just implements that as a warning and ignores that rule, and just says that you should fix this by adding this const, but I know what you mean, so I'll let it work anyway.
I think I'm okay with it just breaking the code personally, but, I know that's not the decisions that they can make.
Yeah.
Yeah, so this is why I said that it's hard to add new things sometimes.
Right.
Okay. Well, you also said that you are working on a couple of papers for C++23, and I saw that there were some from the Prague mailing, I think, with your name on it. Do you want to tell us about what you're working on now?
Yeah, so I had two kind of big language features that I started pushing in Prague. One about just letting you use packs everywhere and making them more convenient, and one that I co-wrote with Vector Boole. What's his real name? Colby Pike.
I was gonna say I have no idea actually.
I just always call him Vector Boole, and about a pipeline rewrite operator. Those are like very different kinds of things with very different magnitudes. So I don't know which one you guys want to
tell us more about the packs to start with?
Sure. So C++11 gave us variadic templates, right? And there are a few very specific places where you can declare packs, basically like function parameters and template parameters, effectively. And we also at the same time got std tuple. And std tuple and a function parameter pack are very kind of similar things, right? They're both, heterogeneous collections of objects. And there are some things that are a lot easier to do with a tuple. There are some things that are a lot easier to do with a pack. But converting a pack to a tuple is extremely easy, right? Like as soon as you understand how variadic templates work, it's very easy to implement make tuple, right? Maybe not std make tuple because it does this extra like reference wrapper unwrapping stuff. But if you ignore that part, like that's a very easy function to implement. Versus going from a tuple to a pack, if what you need to do is perform operations on its constituents, like that's really hard. And not only is it hard to implement, but it's also really hard to use. All right, and we finally got std apply in C++17, which takes a function object as the first parameter, but typically you're gonna, if you have like a function template or like an overload set, you can't use that anyway. So you have to resort to using a lambda, that takes a parameter pack itself, and either way you have to introduce this extra scope. So it's tedious, and all this stuff is kind of like hard to use. And on top of that, tuple itself is pretty difficult to implement, and it's very expensive to compile. Right, so if you look at any kind of metaprogramming benchmark, so whenever anyone writes like a new library and they're like demonstrating how fast it is to compile, their baseline comparison is always, this is what it looks like with std tuple. Well, that doesn't work at all, and it like just like falls over at 200 elements, and here's what it works with my way, right? And I think that's like a really bad state of affairs on a number of levels, and so what this paper does is it tries to like just let you use packs in more places and make them much more convenient to use everywhere. So like on the first level, just like let me declare a member pack, which makes implementing tuple just be like, oh, okay, I just have a member of type t ... elements, and then I'm basically done, right? So that becomes something that's very easy to implement, and that's something that would be very cheap to compile as well. Like I don't have this inheritance tree that I have to deal with. And I would argue that that's pretty easy to understand too. Like once you understand how variadic templates work in general, like there's no surprises there. A second step is indexing into packs. This is something that people always kind of like ask about how to do. Like I have a pack, how do I get the second element? And the answer is what, like stick it in a tuple and use tuple element, but that's expensive to compile. So stick this into this cheaper implementation of tuple that has a cheaper implementation of tuple element. Like these are not really good answers to that. So the paper also just adds a indexing operation into a pack that is just like a direct thing. And the most aggressive part of the paper is directly unpacking. So instead of doing std apply, just a mechanism that you could take a tuple and splat it out into a pack directly. And so you just get as a pack all of its constituents. And so std apply first just becomes very trivial to implement, but also completely obsolete, since why would you ever use it? And it makes, like the whole thing is it makes tuples, and really tuple-like types, just like structs with public members as well, much easier to use.
Does it use the, is it specific to tuple, or does it use the tuple size, tuple element, whatever hooks that are used for also structured bindings? Yeah.
Yeah, so it's built on, the whole thing is built on top of structured bindings.
Okay.
So like unpacking an object goes through the structured bindings hooks to figure out how to unpack it. And there's one part of the paper that in Prague people asked to split out, which was, I suggested like a minor simplification of the like tuple protocol. Since, you can imagine if we could declare an alias pack, if that's a thing, like not just an alias type, but a pack of types.
Okay.
Then you can declare an alias pack named tuple elements, that is your pack of elements. And if you have that as a member, then you don't need tuple size and tuple element. This would be your one-stop shop for all of that.
Right.
So you can reduce unpacking a tuple from 2n plus 1 template instantiations to just n.
Okay.
Which is also a lot cheaper.
So how does this interact with or replace the like for ... kind of proposals that we've seen proposed a while ago? I think have been pushed to 2023 also.
Yeah, so the expansion statements got pushed. They didn't quite finish the wording in time, and there were a few issues that weren't quite done, but that's certainly going to be in the 23 timeframe.
Okay.
And I think these things just work very well together, right? So expansion statements is all about like iterating over a thing, and this is just gives you access to all the things at once. I think they're fairly complementary.
I'm thinking like the history of this. We got variadic templates in C++11, and then in 17 we got variadic using and fold expressions.
Yep.
And then in 20, variadic expansions and lambda captures.
Yep.
I think that
my
sounds
paper
right
as well.
Oh, that was your. Oh, very good. I thought someone else I knew claimed responsibility for that one. Yes. Okay. So, is this the end? Like, have you filled all of the gaps now, or what?
Yeah. I mean, I think this would kind of be like the end all of things you could do with packs. I mean, this paper is roughly, you can declare packs anywhere that you could declare anything, and you can unpack them directly anywhere where you can unpack anything. I don't know that there's any other place to go, at least not that I can think of. Okay, so there is one thing, I guess. So functions returning a pack. This was something that I had in the first draft of the paper. that I removed in the second draft.
Okay.
And that's actually kind of interesting to go through, but probably kind of hard to discuss. But there's a section in the paper that goes through why I removed it, and fundamentally it's like there's two different models you can take for what it means to have a function returning a pack. You can say that this is like syntax sugar for returning like a language tuple.
Right.
So it's one function that returns all of these things, but there's no like overarching object. It's just like a pack. There's another model that is, this is kind of like a pack of functions in which each one is invoked one by one. And there's a lot of interesting benefits of that second model, which is like, well, if I just want the second element of this pack, do I have to, like, how do, in the initial model approach, like that's not a very efficient operation because you have to get everything and then drop everything else.
Right.
But on the other hand, the pack of functions model is, I think, extremely confusing because you look in source and you have one function body, but then when you invoke this thing as a pack, it gets invoked n times, which I think has the potential to be pretty surprising. So I decided that not to pursue that direction at all.
Okay.
I don't think there's a good answer, so I'm not
Yeah.
going to try to pick one of them.
So how was this paper received at Prague?
So it went to the evolution incubator, and it was pretty well received there. So James Tutom pointed out one thing, which was that there's ambiguity in the syntax. So
Of course there is.
Of course, there's always an ambiguity. So actually, this one's kind of fine. So if you have like t's ... open bracket 1 close bracket, that was the syntax I have for indexing into a pack. So that syntax is technically valid C++ today because the bracket 1 could be an array declarator. So that could be a pack of arrays where we basically just ignore the index entirely, and it's this decays down into like a pack of pointers.
Okay.
So only Clang actually even allows you to write that. GCC and Microsoft don't. So saying that we're going to say that this syntax means this new pack indexing thing rather than a pack of arrays thing seems fine. The only code I could find that uses it were compiler unit tests in Clang because it's the only one that supports it.
Yeah. Sounds like you're fine then.
Yeah, I think we're okay on that part. So next step is evolution there.
That's interesting. The only code that uses it is compiler unit test.
Yeah.
Huh.
I mean, it's like a weird thing to want to write because you need to declare like a pack of array,
right?
Which is weird because that's a pointer, and you can already declare pointers, and you need to not name the parameter because if you stuck a name in, the name would go between the ellipsis and the bracket, and then it wouldn't be ambiguous anymore. So it's a very like specific kind of thing that you really have no reason to write to begin with.
Right.
So that one's not a huge concern for me.
Okay.
No other.
And I'm sorry. What was the other paper that you said you were proposing at Prague? The other big one.
So that one's the pipeline rewrite operator. So this one's kind of interesting because it's as far as the actual proposal goes. It's quite small, and I've actually implemented it in Clang, and I've never implemented anything in Clang before, and this didn't even take me that long. Like it's a very small kind of thing, and so what it is if you're familiar with ranges, so what ranges introduces is this like pipe syntax, right? So you have like X is pipe filter F, and that gives you a filter view that only gives you the elements that are that predicate applies to, and that's a nice way of writing it because we write like the range on the left, and then we can have this like chain of operations that we apply to it on the right, and the way that works is that filter is an object that has to have two overloads, right? It has one that takes a range and the predicate that gives you a filter view. It has another that has a predicate that returns something that's left pipeable with a range. And this is like a little bit tedious to implement. It's a little bit tedious to compile, but it's not like a huge amount. It's a handful of lines per algorithm that you need to do this for. Which the standard library has hundreds of algorithms, so a few lines per algorithm certainly like adds up over time. But the thing is, like, this is stuff you have to write. It's a lot of boilerplate. It's a lot of overhead. And so one of the things that I'd like to do is I'd like all the standard library algorithms to be pipeable like that. And right now it's just the range view adapters. So I have a choice of like, well, am I going to show up to the committee with a paper saying that like I want to pipe support for these 100 plus algorithms? That's a lot of work. But even if you set aside all the boilerplate aspects of this, some of these are just like fundamentally ambiguous, and you can't even support that way. Because in order for the pipe syntax to work, you have to be able to distinguish between the cases where you have a full call, like filter range comma predicate, and a partial call, like filter predicate.
Okay.
And if you can imagine, like in ranges specifically, we always have a range as the first argument. So what if your algorithm can take a range as the second argument as well? How do you differentiate between those cases? So like a couple examples are like zip, right? So zip A is a totally valid thing. I'm just taking a single range and zipping it. I mean, it's not super useful, but it's certainly like a valid thing. So like, how do I make zip A comma B and A pipe zip B both work?
Okay.
And you can't. So like range v3 makes the choice of only allowing you can't pipe into zip in range v3, just like you can't pipe into concat. And this is a choice that you have to make. You have to go through every algorithm and try to figure out if it has an ambiguity, and if it does, how to address the ambiguity. Join has another kind of interesting one where it's like if you want to have a delimiter and your delimiter is something that could hypothetically be joinable, you have to figure out what to do with that, right? And so range v3 just names those things differently. And accumulate, as far as other algorithms, so has a similar problem, right? Right now we don't default all the other arguments, but like hypothetically we could. And if we did, then accumulate range could itself be ambiguous. Is that, am I accumulating this range, or is this like the initial value of something that I'm going to accumulate later? So fundamentally we have this, these issues where like, this is really nice syntax, it's really easy to read, but it's a lot of boilerplate to support, and then we can't even support it for every algorithm because we have ambiguities. So what the proposal is just like a new operator in a language that's not overloadable, so you can't, no shenanigans. And it's spelled pipe greater than.
Pipe greater than, okay. So, okay.
Yeah. And the right-hand side, yeah, it looks like an arrow. And the right-hand side of that looks like a function call. So you have like x, pipe greater than f, open paren, close paren. And what that means is that means exactly we take the thing on the left and we stick that into the first argument of the thing on the right.
And then what is the result?
The result is the result of that call expression. So in that example, so x, pipeline greater, f, open paren, close paren, evaluates exactly as f of x.
Okay.
There's no intermediate f, open paren, close paren expression at all.
Okay. So if f takes more than one parameter, it's not going to return you a curried function or something like that.
Right, exactly. So if you did like x pipeline f of y, that's f of x comma y.
Okay.
And so that's it. That's basically the whole paper. And so what this lets you do is, so all the range view adapters just like work directly. You just use pipeline instead of pipe because they already support the total call syntax. But then for free, you get all the other range adapters that don't have pipeline support, like zip and concat, because there's no ambiguity issue, and all the standard library algorithms for free with no code changes necessary, and everything that has nothing to do with ranges everywhere else that you might have wanted to do this, right? So there's an example in the paper. Eric and David Holman gave this talk about the new sender-receiver model at CppCon. And they had this example where like they just had an algorithm and they had a few then calls and then they like block waited for it. And so the paper has an example where I rewrite that using pipeline, and it's just like this nice linear flow of operations. It's staggeringly easy to read. Again, no work. Like it's not like I need to be like, hey Eric, I know you have all this free time with not dealing with other sender receiver issues. Can you also add, this extra pipe hook? And no one has to do anything.
So what if you pass it a member function? I mean, what if the member function's on the thing on the right-hand side? Is that the this pointer then? Or does it not compile?
So one of the things that we still have to discuss is the way that we picked the grammar. Is that the thing on the right-hand side is primary expression. So if you wanna invoke a member function, if you want to pass it to like vector.pushback or something,
Right.
You have to parenthesize that right now. According to Barry, it has to be like open paren v.pushback close paren, open paren close paren. So that's not where we want to go. Like we definitely want you to call a member function there. That'll work fine.
Okay.
So did the committee have a chance to review this paper at Prague?
Yeah, so that also went to the incubator. And the grammar issue is one of the things brought up. Another thing that brought up that I really hadn't thought about was precedence. So where in the precedence scheme does pipeline fit with other operators? So the way that Colby and I picked it was that since it kind of matches dot and arrow pretty closely, that we just stuck it in the same world as those. They behave exactly the same way. So if you have like a call chain, you can just interleave dot and pipeline and arrow, and that still reads left to right. But there were a few questions from several people about like that we should consider making the precedence lower, so that apparently it's more common in other places to want to avoid having to parenthesize things all the time.
Right.
And so that's something that I've not taken the time to explore yet. As to what the precedence of these things should be.
That is an interesting one.
Yeah.
So I was thinking about that, like, I don't know, I feel like there's some sort of implication here that you explicitly say it will not be overloadable. It's the only other operator that's not overloadable, dot.
Scope isn't overloadable.
Oh, I don't think of it as an operator. Okay, yeah.
I believe there's one more. It's like arrow star. No, arrow star is overloadable.
No, yeah, that's overloadable.
There's a list of non-overloadable operators.
Yeah, but it's short.
Yes, it's very short.
Interesting.
Yeah. Do you want to tell us a little bit more about your obsession with Stack Overflow? How much time you spend answering C++ questions there?
Too much. I think that's the only correct answer. Yeah, no, I'm on there, daily, seeing what the new, lately I pretty much only look at the C++ 17 and C++ 20 questions, and, I try to answer all the interesting ones. What with my involvement in Spaceship, I'm always annoyed when there's a comparison question, someone beats me to it. It's like, come on. But no, it's great because, one, it's a good way to like give information back to the community because, I follow this stuff a lot more closely than most people, and people do ask, very interesting questions, and some of them are like, oh, this thing is actually really hard to do, and maybe it should be easier to do, or I find a lot of people ask the same kinds of questions, so this is kind of how I gauge things that are generally confusing versus, this is like, this is something one person asked one time, and not this is a question I see 4 times a week. Right. Is a different kind of thing.
So I don't know. I'm afraid this question will sound silly, but I'm actually very curious where that fits on the like resume. Like if you're like number 1 C++ Stack Overflow answer, is that like resume cred or? Do you know?
I mean, I would probably put it on my resume. I have seen people post Stack Overflow profiles on resumes.
Yeah, I think, a few years ago, well, now at this point, a long time ago, I had mine on there, but I haven't been on Stack Overflow and to answer a question in probably 8 or 9 years or something, so I just don't think about it. Does that sound right? How old is Stack Overflow now?
It's all, I think, 2008 maybe.
Yeah, okay, so I'm not crazy. Yeah. So, so I mean, but there are certainly, I would say, probably a large group of people who know you because of Stack Overflow.
Yeah, probably.
That's
I'm
interesting.
certainly on there enough that I'm ubiquitous. I mean,
So-
it is a good way to demonstrate competence, right? Like if you write a lot of answers and you write like high quality answers, that is like a really easy way for, someone to look and see that, oh yeah, this is a really good answer. You really understand the topic.
Right.
Like I can save, that all that, interview process because, well, this is good demonstration of that.
Why are you asking me these questions? Just look at my Stack Overflow profile.
It's shorter. I mean, one of the things that answering a lot of questions does is it helps me remember where to go to look for answers really quickly.
Mm.
So in particular, like I know where a lot of things are in the standard just because I've had to look them up so many times before that I just know that, oh, I see this question about like, GCC is accepting my code, but Clang is giving me the error. Who's right? And I'm just be like, oh yeah, no, that's temp.res 8. They're both fine, right? It's just like I know where these things are enough, and that's really helpful. Especially when it comes time to writing like core wording for my papers. It's like, okay, I know I've seen enough of this, and that's why.
So we've already established that you can't really talk a whole lot about what you do in your day job, but if you can, just out of curiosity, your papers, are they mostly driven by what you see on Stack Overflow, what you experience at work, or your personal interest?
Kind of a mix of like what I see on Stack Overflow and what I do in my day job.
Okay.
If there's like an overarching theme to all the things that I've been proposing, it's like I can do all of these things and I have done all of these things, but these things are way too difficult and I don't actually like, why am I spending all this time doing this kind of thing? I want this to be easier for everyone.
Right.
All right. So like I've implemented optional and I've implemented a trivial propagating optional. And for anyone who's done it, like that's a lot of work. It's a lot of code and it's just like silly, right? So one of the things I pushed for 20 was to make it easier to propagate triviality for types like optional because I've done this and it's unreasonably difficult and that's like not beneficial.
Did we get it? Was that approved for 20?
Yep, that's in 20.
What does that look like? Is that some feature that I missed? Core language feature, library feature?
I consider it as fixing a core language defect kind of, but so if you have a constrained defaulted copy constructor.
Copy constructor, okay.
And you have a constrained non-defaulted copy constructor, right? So optional, for instance, would have a constrained copy constructor that's non-defaulted and a even more constrained copy constructor that is defaulted.
Okay.
And the rule is that still counts as being trivially copyable. So the rule used to be that we look at every copy constructor, which would consider both of those, and every copy constructor has to be trivial or deleted. And the new rule is that we only consider the most constrained one.
Okay. I think I saw that wording, but I didn't. Yeah, okay. Okay. And is this also a utility that applies for trivial destructibility as well, which comes up with optional?
Yep.
Okay.
All the special members, right? So it's the small like core wording language rule change that fundamentally means like what you would expect it to mean, right? Like, it's only the one that would actually be invoked that matters for triviality.
Interesting.
And so what this means is like I can implement a standards compliant optional without any base classes at all, which is nice. It saves an enormous amount of lines of code and is staggeringly more readable as a result.
So this is if I were to have a concepts constraint on my destructor versus one that's not constrained, it will do the right thing.
Yep. So
I
for
have
optional,
got to play with that. Sorry.
Yeah, so for optional specifically, you'd have a normal destructor that is like, if engaged, explicitly invoke the destructor of the member. And then you'd have another destructor that is requires trivially destructible T equals default.
Right.
And that's it.
That actually answers several questions that I had recently about, I guess, wording that you added, because I'm like, how do you write more than one copy constructor? Now I understand. Okay.
Yeah, and now we can have more than one destructor.
I sorry, I'm excited about that. Thank you for your contribution to the committee.
You're welcome.
Yeah.
I'm also, just for the record, excited about being able to put variadic expansions in more places because I totally see the utility for that as well.
Yeah. Okay. Well, it's been great having you on the show today, Barry.
Yeah, it's been great being here.
Yeah, thanks for coming on. I was just making a note for a future C++ Weekly episode.
It's not going to be on anyone's, top 20 list of C++ 20 features, but it's definitely handy.
I know it is very interesting, actually. I think I can easily see people who have not appreciated what you did, like me, just now having their minds go like this. So, yeah, thanks.